Okay, we're jumping into a new chapter now. This is going to be all about statistics, and it's actually our final chapter of the year, but don't get too excited. We have lots of fun stuff, so we're going to do as much as we possibly can for the last few weeks of school. So it says it said before you use measures of center and measures of variation. What that means is what we've done before is descriptive statistics, where we have done mean, median, mode, that kind of thing, and measures of variation, a little bit maybe of standard deviation and range. But now we're going to get into inferential statistics, which is more big kid statistics. So things might get a little bit more interesting, I hope, than just your basic mean, median, mode, that same stuff you've been doing since whatever, 5th grade or something. So we're going to talk today about samples, surveys, experiments, observational studies, and then make inferences about population parameters based on random samples of the population. And what that means is when you are trying to get information, a certain population characteristic, which is a parameter, get some information about some kind of population, it's not always reasonable to survey or experiment or observe the entire population. And so we go with these samples. Okay, I'm going to keep moving on, but samples are just a small part of it. I will give you some examples, I think, throughout this lesson. Okay, so statistics itself is, it's a study of data, mostly the collection of data, analyzing it, interpreting it. Yeah, I think. Well, actually, the definition is statistics is a collection, analysis, interpretation, and organization of data. Okay. That's that. Parameter, I actually mentioned, it is a population characteristics. It's something you want to know about a population. And a statistic is a measure taken from a sample. So for instance, I'm just going to go with a population and sample random example here that I'm making up right now. Say you want to know, like, hey, how many people live in a household in America? Okay, so your population is every household in America. Now, it's not very realistic for you to go door to door or survey or question every single household to find out how many people live in their household. By the time you get from one side of the United States to the other, a bunch of people will have died or be born anyways, so it's not going to make a lot of sense. So instead, you're going to choose a certain sample. And how you do that, you want to make it as random as possible, and ideally, although again, not very realistically, you would put everybody's household names in a hat, and you draw out a few hundred, and then you would get a hold of them and get their information. But that information then is a statistic. Okay, moving on. A bias. So a bias can be from a sample itself, or it can be in the survey, like in the question. And when it's in the sample itself, a good example of this would be like, hey, let's pretend we want to know if our school prefers wrestling or boys basketball. And so what I do is I go survey the wrestling team. And I find out that like 99% of them prefer wrestling. And then I wrongly assume that means that our whole school, that 99% of our school prefers wrestling. Okay, so that bias is in the sample. And then bias questions are usually pretty easy to pick out because they're like, hey, how about a super duper delicious greasy cheeseburger or a yucky boring plain salad? Like, it's pretty lame. At least the ones in our book and stuff are pretty obvious. Okay, and so a random sample I kind of already explained because you want every one to have an equal chance of getting picked. All right. Survey, experiment, and observational study. Those are the three types we're looking at today, and I think they're on the next page, so I'm moving on. Okay, in a survey, data are collected from responses given by members of a population regarding their characteristics, behaviors, or opinions. Now, a survey is an easy, convenient way to collect data. It's not always unbiased, however, especially in those ones that it's like at the end of eating out at a decent restaurant, okay? They'll have like a survey at the end. Well, it's volunteer. So only if something really good or really bad happens do people usually respond to those. So you got to take that into consideration. An experiment, this is where, and it's very important, you probably know from science, is you have to have a control group and an experimental group. The control group is just the same as it always is, and the experimental group is the one that you're testing whatever change that you want to find out about. And an observational study, those are where you literally are not changing anything. They don't even know you're there observing them. One example I can think of was way back at NDSU going into child development family science, and we had to observe like the preschool as I don't know. We stood outside the windows. They didn't know we were watching them, but we could observe them playing. I don't even remember the point of it, but I keep babbling and I want to make this quicker than normal. So moving on. So you're going to pretty much state if it's a survey, an experiment, or an observational study. So a retro movie theater wants to determine what genre of movies to play during the next year. They plan to poll 50 random area residents and ask them what their favorite movies are. All right, I guess I'd have to say that's a survey. Again, here's another one. Oh, and it says identify the sample and suggest a population. Okay, I can do that too. A driving school wants to determine the main issue drivers face while taking the driving test. They watch and record 30 random people taking the test. While they're watching and recording, that's observation. Their sample are those 30 people that they end up observing, and the population then, depending on, this doesn't always give the full story. It could be all drivers starting to take a test this year. I'm not sure. Everyone in the driving school, it's hard to say. You can kind of make this stuff up. One thing I should mention about statistics is that it is so different than math. It is not your black and white. It takes context, and you have to understand and reason and use logic. And quite frankly, if you're like me with black and white math, this stuff is actually much more difficult. Whereas I like if you're not like me, if you're good at English and interpreting and comprehension, then hey, this is going to be probably pretty easy for you. So, moving on. Okay, this one I kind of want to talk about. It says a restaurant manager provides a new entree to 30 randomly selected tasters and observes their reactions. Okay. The book or this PowerPoint, I think, says it's an experiment. Now, I feel like they're not giving us the full story. If they want it to be an experiment, they need to say that the rest of the people, the rest of them did not get the new entree. It's just, I don't know. So they should have had a control and experiment basically explicitly discussed in this, in my opinion. So I guess experiment it is. Okay, a gaming company plans to test whether a new controller is preferable to the old one. A group of teens will be observed while using the controllers to see which one they use most. That one is just an observational study. A restaurant wants to conduct an online study in which they will ask customers whether they were satisfied with their dining experience. That's a survey. A research firm wants to test the effects of a new health drink. Okay, so there the word test is in there. So I would probably say experiment just because of the word test. And I guess that is assumed you have a control and an experiment group. Okay, here is where we get to do a little bit of math, though not much. And the first time I actually get to write on this thing in purple. It says a random sample of the 922 people at the concert were surveyed and asked to name the type of music they listen to most often at home. Based on the results of the bar graph, what's the most reasonable inference about the number of people at the concert who would say that jazz is the type of music they listen to most often at home? Okay, so there was 922 people at the concert. So that is our population. Our sample are the number of people that were actually surveyed. I gotta find a good, oh, no, go away, go back. Okay, so what we need to do is figure out jazz is 10, but 10 out of how many? So we just need to add up and see how many were actually surveyed. So we have 40, 50, 95. So 10 out of 95 people were surveyed. So that's the percent when you divide that. That's the percent from this sample. And we're going to apply it to infer about the population. So you're going to take that 10 over 95 and just multiply it by the 922. Right? And I do not have my calculator, so we are going to click through it. Yep. So the 10 over 95 was about 0.1053. They multiplied by 922, so it looks like 97, approximately 97 people who attended the concert listened to jazz most often at home. So that's your answer. So a good chunk of your assignment is going to be that, where you just need to find the percent that is given in the sample and then just multiply by the number in the population that they'll define it for you. I think this slide is in the wrong spot, so we're moving it over here. Okay, so we're talking about bias in these last few slides. It says a university wants to redesign the mascot it uses for each sports team. An administrator surveys a random sample of the football team to see whether the school's athletes want the same mascot with a new design or a different mascot entirely, and finds that 10 of the 20 respondents want the same mascot. From this, the administrator determines that approximately 1,532 of the university's 3,064 athletes want the same mascot. Identify and explain any bias, I can't talk as normal, that might affect the validity of Jamar's inference. Okay, so you can reread that so it makes more sense to you if you want. But basically, they used a very small sample, just the football team, and found that 50% of them decided they wanted the same mascot. And then the administrator, in fact, wrongly decided or wrongly assumed then that would generalize to the entire university's athlete population. And so how you would want to explain this, I guess, would be like they took too small of a sample with no variation, then it wasn't a random sample, and I'll see what they say. Maybe. Because the football team is a specific group of athletes, they do not reflect the university's entire athlete population. Thus, the administrator's inference might be affected by the bias in his survey. I bet that might be is most definitely. Okay, and this one is just to see if you think the question is biased. It says, are you planning on watching the ultimate sporting event, the Super Bowl? Okay, well, their answer is that the question encourages a certain response and therefore is biased. Like I said, they're pretty obvious when they're biased. Oh, okay, so I guess that's it. I believe your assignment is page 534, 7 through 22 all. I don't know, I might post the answers, I might not, but it should go pretty quickly. Let me know if you have any trouble with any of the parts. Also, if you on 9 through 12, you do not need to explain your reasoning. Otherwise, yeah, you should be fine. Okay, have a good day and see you guys on Friday.